All right, welcome back. So today we're doing lesson 2 of organic chemistry. We're taking a look at functional groups. So we're in 8.2, and again, the title today is functional groups. All right, so start off by taking a look at what functional groups are. They're combinations of other atoms other than carbons and hydrogens on a hydrocarbon. So last week when we were looking at our hydrocarbons, there was just a lot of carbons linked together with H's coming off of them. Now we're going to be looking at other functional groups, some other things are coming off of there. Now, in this class, we're only going to look at 2 different functional groups. There are several others. So if this is something that interests you, if you like organic chemistry, you want to learn some other functional groups, we have a whole semester-long class here at this school called organic chemistry. So you can consider taking that perhaps next year, and if this is something that interests you. So starting off, we're going to look at alcohols. Yes, the alcohol that adults consume is one of these, but it's only one of several thousand alcohols. So let's take a look at what these are. So alcohols have what we call a hydroxyl group, which is the OH somewhere on that chain. So whenever you're looking at that for that OH, you've got yourself an alcohol. Alcohols end in OL. So when you're coming up with a name for them, you end your term with OL for an alcohol. Take a look at a couple of examples here. All right, so there's your alcohol. The rest of these will fill up with hydrogens. Now, when we come to name this structure, again, it's going to be the exact same as what we have been doing. Our base is going to be how many carbons we have. I see 4. So our prefix for 4 carbons is but. All single bonds between those carbons, so AN, butane. But instead of putting an E, we're going to change the ending to OL because of the alcohol. So this is butanol, butanol. Now, just like with our double bonds, we need to specify where that alcohol is. There's a terminal alcohol, it's on the end. And if we went left to right, we'd say 1, 2, 3, 4. It's on the 4th carbon. But remember, organic chemistry, we can go left to right or we can go right to left. There's no rule either way. So going back right to left, 1, 2, 3, 4. The rule is you have to get the lowest number. Right to left to right, doesn't matter. If we go right to left, it's 1 butanol, so that's how we'll name it. And that alcohol, that hydroxyl group, is on the end of the chain. It's a terminal hydroxyl group. We could have it in the middle of the chain, and then we'd call it an axial alcohol, so coming off the side. Take a look at one of those. So 3 carbons. This time, the alcohol is on, or is in the middle. So we'll go ahead and name it. Again, prop for 3 carbons. AN, they're all single bonds. OL at the end, propanol. And then if we go left to right, 1, 2, it's on the second carbon. If we come back right to left, 1, 2, it's on the second carbon. So it doesn't matter which way we go. It's going to be on the second carbon. This is 2-propanol. Again, prop for 3 carbons. AN, all single bonds. OL for alcohol. 2 on the second carbon. And that's alcohols. Our next functional group are called carboxylic acids. Again, we're only going to cover 2 for this class. If you would like to know more, if you like this stuff, you can always take our semester-long class next year. Our second group is called the carboxylic acid. So carboxylic acids have this strange looking structure with what looks like an alcohol, and it is kind of, but the big difference is it's attached to a carbon, and that carbon is double bonded to an oxygen. We call this a carboxyl group. So there's a carboxyl group there. So that's what you're looking for. Again, I know it can be easy to confuse this with an alcohol. It does look like an alcohol. Always look for that double bonded O to signify that you're working with a carboxylic acid. Carboxylic acids end in oic acid. So that's how we know we're working with a carboxylic acid based on the name. And then one special little note here. So because this must be on the end of a chain, I mean, look, this is the last carbon. We can't go more in this direction. This is going to be the end of a chain. This carbon has all 4 bonds. So because it must be the end of the chain, we don't need to add numbers. It's going to have to be number 1. And anyone else who knows what carboxylic acids are knows that it must be number 1. So we don't have to put numbers. In fact, we shouldn't put numbers. It's redundant to put that number 1. So let's take a look at a couple examples of carboxylic acids. Here's the simplest of them, just 1 carbon. Again, it looks like an alcohol. Big difference, we've got that double bond to O there. 1 carbon, the prefix is meth. All single bonds. So methane, but we're going to change the ending to oic acid. This is methanoic acid. Can take a look at the parent chain, 1, 2, 3, 4, 5 carbons. Again, it looks like an alcohol, but it's also got that double bonded O. That's our carboxyl group. We're working with a carboxylic acid. 5 carbons is pent, all single bonds. So AN, end it with oic acid. So pentanoic acid. All right, again, as I've been saying a few times already, there are a lot of other functional groups. So if you like this kind of stuff, consider taking organic chemistry next year. But those are the only functional groups we're going to work with for this class. So and that does it for us. All right, have a good one. I'll see you.